I just wanted to show you how much you can grow your brain today. I thought maybe we would know most of what was on this test assessment right away, but maybe not. So this area right here is where we should be showing your work. So if you didn't show any work, you probably lost a point there. We're talking about perimeter and we're talking about area. When we talk about perimeter, we talk about the distance around something. So that would be adding all the sides. So in this case, perimeter would be 6 plus 6 because that's 6 and that is 6. And then this is 9. And then this side is also 9. So we got 9 plus 9. And then when you added them all up, you ended up with a 12 plus 18, which would have given you 30, and then another point for feet, because that's how much it is all the way around. So that's that part, and this part over here would be the area part. And when we talk about area, we talk about something specific about the surface of something, and to do that, you hopefully know that area is when we talk about the covering of something like a tile or like a tablecloth. And that would be multiplying length times the width. And in this case, 9 times 6, which is equal to 54. When we do area in 54 square. And in this case, it's not units, but feet. So this particular problem, number 4, is very similar to number 1 because it's asking to do both perimeter and the area of this pig pen. But the only thing that's missing here would be the other sides. So it's pretty simple. Since it's a square, we know that each side is worth 7. So if we're looking at perimeter, we know that that is 7 all the way around. So we have 7 plus 7 plus 7 plus 7, which is going to be equal to 14 plus 14, and in this case that would be 28. So that's your perimeter. And area is pretty much the same thing. Now, the only thing that might have confused you on this one is that since it doesn't exist, or the other sides do not exist, you'll see that 7 feet, you have to add how many boxes high, how many boxes wide, and there aren't any boxes in the middle, so you simply just add or multiply 7 times 7, which would be, in this case, 49. But when we do the answer, we have to make sure that we label it with the correct answer. In this case, it's feet. So we have 28 feet as our perimeter, and then 49 for the area. But the area, once again, is always in square units, or in this case, squa feet. And that would be how to find the area of a square and the perimeter of a square. So here's David's bedroom. Doesn't look exactly too easy, but really it's super easy. You have to think of David's bedroom as being 2 shapes instead of this giant big shape here, which kind of resembles 2 different shapes if you think about it. So really what we're thinking about here is what we need to do is to kind of divide this up into 2 different shapes. So now we are going to deal with the area of this shape in here. We're going to do the area of this shape in here, and then we're going to deal with the area of this shape in here, which is right here. So this one is simple right here. I would get rid of my 14 feet because I've chopped up this top line, so it's no longer 14 feet long. I do not have to worry about this 5 feet because now I'm dealing with the height of the entire side. And then I have this tiny little box over here, this 4x3. That one's simple. All I have to do is multiply 4 times 3, and that's going to give me 12. And then I'm going to take this big one over here, and the big part is going to be an 8 by 10. And that's 8 times 10, and you probably know that is 80. So 80 plus 12 is 92 square feet. And that's basically how you find the area of a shape that has several shapes in it. And that's what you need to be thinking of when you do an area for a bedroom. Okay, so here's a little review of some shapes. Letter A is asking us to find all the squares. And the squares on the page are shapes that have 4 equal sides. And in this case, that would be number 10, and that would be number 7. Number 7 is a little weird because you have to like twist the square around. Some of you say, well, that's a diamond. Well, really it is a square because it has 4 equal sides, 4 right angles, and that would be a square. So the next one would be our green color, and that is coloring all the trapezoids. And the trapezoids in this case would be number 4, which is your classic trapezoid, and actually number 9. And the reason that number 9 is one is because it has one set of parallel lines right here, but then it has another set of lines that are not parallel lines, and that would be these two right here. Those are not parallel lines. So that would be all the trapezoids. And then the next one would be our purple, which would be, let's pick that for purple. And the purple ones would be the rectangles. And that's pretty easy. Most of you got those. Those are the two here. They have two pairs of equal sides. So one pair is longer than the other pair. And that would be that one. Rhombuses. The rhombuses ones were a little bit different because maybe you forgot what a rhombus is. It's like a square, but the only difference between a square and a rhombus is that it does not have right angles, and that would be these 3 right here, 5, 3, and 6. And then after that, we needed to draw a line underneath of every single shape that was a quadrilateral. This has 4 sides, 1, 6, 11 also has 4 sides, 12, and 7. Also, 3, 8 is a hexagon, so that doesn't get 1. This one has 4 sides, and these 2 are trapezoids. They will. That rhombus does, and that square does. But that's a pentagon for 15, so it wouldn't. And that would be your review of shapes. Let's take a look at number 8, which is basically doing fractions again. But the weirdest part for what threw a lot of you was the fact that we saw these tiny little dots in here. And these dots really threw everybody for a loop. But really what you need to do is to think of this as an actual square. And if the dots weren't there, I'm pretty sure most of you would understand that what they want you to do is to do 4 parts of the same area, which are 4 equal parts. And then name the fraction of each part. I'm going to circle each there. Because really what they wanted is they wanted a unit fraction. So 4 equal parts could look like this. It could look like this. It could look like this. It could look like this. So those are just some of the ways that it could, but each one in there would be 1/4. So each one is 1/4. So name the fraction of each part, and that would be 1/4. And yeah, it's basically they just kind of threw you for a loop with the wording and the geoboard that's on there. So that's actually a pretty easy couple of points there.